Here is question number 21, everyone. Two polarites are placed such that their plane are parallel to each other with their axis of transmission at 30 degree. If unpolarized light of intensity I naught incident on the first polarizer, then intensity of light will be transmitted through the second polarite will be. Now, suppose this is the unpolarized light, and we know very well after passing through the first polarizer, the intensity reduced to half of its initial intensity. Means if unpolarized light have I naught intensity, then after passing through the polarizer first time, the intensity will be I naught by 2. Now there is another polarizer whose transmission axis is making an angle 30 degree with the previous one. So according to law of Malus, the intensity of light here will be given by I equals I dash cos square theta. I dash is what? I naught by 2 multiplied by cos 30 square. Solving it, we'll get I as I naught by 2 multiplied by cos 30 root 3 by 2. Let's square it, 3 by 4. So the intensity will be 3 I naught divided by 8. Option number 4 is perfectly matching, so we will go on with option number 4 only. Now move on to the next, that is 22 number. So here is question number 22, everyone. In the given circuit, current through 2 ohm resistor will be what? We have to calculate the current flowing across this. First of all, let us modify the circuit to understand properly, to do the question simply. Junctions, suppose this is D, this is A, B and C. Now from here we can write A and C directly connected to the wire, so they will be at the same potential AC, common point. Similarly B and D, they are also directly connected with the wire, so they will also be at the same potential. We have a 3 ohm resistor between A and B, 3 ohm. We have a 6 ohm resistor between B and C. So here is C, here is B, 6 ohm. And we have a 2 ohm resistor between C and D. So here is C, here is D, 2 ohm. Now A is connected with another 1 ohm resistor. This 1 ohm is connected with positive terminal of battery. The negative terminal of battery is directly connected with D. So this is the modified circuit, which is quite simple now. Now the total resistance will be, they will together makes 1 ohm plus 1 2 ohm, potential difference 10 volt. So the total current I will be what? 10 by 2, that is 5 ampere. 5 ampere current will be the total current drawn from the battery. 5. The potential difference across this 1 volt will be what? 5 into 1, 5 volt. And rest of 5 volt will be distributed or will be there in this parallel combination. It means since they are in parallel, so 5 volt, 5 volt, 5 volt. Therefore V across this 2 ohm is also 5 volt. Now we have to calculate potential across 2 ohm is 5 volt. So I across this 2 ohm will be what? V by R, that is 5 by 2. And we get 2.5 ampere. It means option number 2 is absolutely correct. We'll go on with option number 2. Move on to the next, that is 23 number. So here is question number 23, everyone. In the circuit shown in figure, the energy stored in capacitor at steady state will be what? Energy stored in a capacitor given by half CV square. Now C is known for the capacitor given in the question. V we have to calculate. The question talks about steady state, and we know that in steady state capacitor acts as open circuited. So if it is open circuited, then this circuit has no part or no any contribution in the flow of current. We can remove it. The circuit now can become 2 ohm, another 2 ohm, 4 ohm, 10 volt battery, 1 ohm resistance, this 2 ohm, this. Now B and D are two important points. B and D will be the potential difference across this capacitor. We have to calculate this V is actually VB minus VD. 4 ohm, 2 ohm, another 2 ohm, 2 ohm and 1 ohm. The potential difference of battery is 10 volt. The EMF of battery is 10 volt. Now the total resistance we have to calculate 2 to 4, parallel of 4 with 4, 2 to 4 plus 1 5. So the total resistance we have got 5 ohm. It means the current drawn from the battery will be what? 10 by 5, that is 2 ampere. 2 ampere is the amount of current drawn from the battery, and this 2 ampere current flows like this. Here current distribution will occur. 4 ohm this side, 4 ohm this side. So current will distribute equally. 1 ampere right here, 1 ampere right here. Current will be combined right here, and again 2 ampere in this. We will require VB minus VD. Now let's apply the Kirchhoff's voltage law from B to D. Let's travel. VB minus 2 into 1 IR minus 2 into 2 equals VD. Therefore VB minus VD will be what? 2 plus 4, that is 6 volt. Energy stored in capacitor will now half C, that is 4, V square, 6 square, 36. This comes in microjoule because capacitance we have taken in microfarad. The total energy stored in capacitor thus now be 72 microjoule. Means option number 3 is absolutely correct. We have to go on with this third option only. Now move on to the next, that is 24 number. Here is question number 24, everyone. An alpha particle is accelerated through a potential difference of 100 volt. Its de Broglie wavelength will be what? Now if any particle like alpha or electron or proton, if it is accelerated by a potential difference V, then the wavelength or de Broglie wavelength is given by lambda. For electron it is 12.27 angstrom divided by under root V. For proton it is 0.286 divided by under root V in angstrom, and for alpha particle it is 0.101 divided by under root V angstrom. Here alpha particle is mentioned. So for alpha particle, lambda alpha, we can write 0.101 divided by under root 100 angstrom, and after solving we get lambda as 0.001 in nanometer. We have to calculate not in angstrom but in nanometer. So option number 4 is absolutely correct. We will go with fourth one. Now move on to the next, that is 25 number. So here is question number 25, everyone. In a photoelectric experiment, the wavelength of incident light changes from 4000 to 2000 angstrom. The change in stopic potential will be what? Now we must be knowing the energy of incident photon given by E equals hc by lambda. Now if we write this energy in electron volt, we can directly write 12400 by lambda electron volt. So in first case lambda is 4000, so therefore E1 we can write 12400 divided by 4000, which gets you 3.1 electron volt. Similarly in second case, if wavelength is 2000, lambda gets half, energy will get double. So E2 will be what? 6.2 electron volt now. Writing the stopping potential equations, we know that EV0 is energy of incident photon minus of work function. So in first case, EV1 equals 3.1 minus phi, equation number 1. In second case, EV2 equals 6.2 minus phi, equation number 2. We have to calculate the change in stopping potential. Now let's do second equation minus first equation. We get E times V2 minus V1 equals 6.2 minus of 3.1 electron volt. Now V2 minus V1 we can simply write electron and this electron volt we can cancel out. So here V2 minus V1 will be what? 6.2 minus 3.1, that is 3.1 volt. So delta V is 3.1 volt. We will go on with option number 2 only, which is absolutely correct. Now move on to the next, that is 26 number.